Hello and welcome students to the class of business statistics. In the last class, we were just discussing about the various types of graph, right? So, histogram and frequency polygon was done. In this class, we will discuss about the smooth frequency curve and the cumulative frequency curve. Let's start with smooth frequency curve. So, smooth frequency curve is just a part of frequency polygon, but there is a slight difference. So a smooth frequency curve can be drawn through the various points of polygon. The curve is drawn freehand in such a manner that the area included under the curve is approximately the same as that of the polygon. The object of drawing a smooth frequency curve is to eliminate as far as possible accidental variations that might be present in the data. While smoothing a frequency polygon, the fact is that it is really derived from the histogram should always be kept in mind. This would imply that the top of the curve would overtop the highest point of the polygon, particularly when the magnitude of class interval is large. The curve should look as regular as possible and sudden turns should be avoided. The extent of smoothing would the extent of smoothing would, however, depend upon the nature of the data. If it is natural phenomenon like tossing of a coin, smoothing may be freely resorted to as such phenomenon normally has symmetrical curves. But if the phenomenon is social or economical, the curve is generally skewed, and as such smoothing cannot be carried too far. The following points should be kept in mind while smoothing a frequency curve. Only frequency distribution based on samples should be smooth. Only continuous series should be smooth. The total area under the curve should be equal to the area under the original histogram or polygon. Then the second one, cumulative frequency curve, or we can say ogive. At times, we are interested in knowing how many workers of a factory earn less than rupees 700 per month, or how many workers earn more than rupees 1000 per month, percentage of students who have failed, etc. To answer these questions, it is necessary to add frequencies. When frequencies are added, they are called cumulative frequencies. These frequencies are then listed in a table called a cumulative frequency table. The curve obtained by plotting cumulative frequencies is called a cumulative frequency curve, or I can say ogive. There are two methods in constructing ogive. First is less than method, the other one is more than method. Less than method, in the less than method, we start with the upper limits of the classes and go on adding the frequencies are plotted. We get a rising curve. Then more than method. In the more than method, we started with the lower limits of the classes, and from the frequencies we started subtracting the frequency of each class. When these frequencies are plotted on a graph, we will get a declining curve. So there are two methods. First is less than ogive, second one is more than ogive. Less than ogive will look like this. As you can see in the graph, it is a rising curve, right? So basically, whenever we are having the frequencies like this, or I can say cumulative I can say class intervals like this and the frequencies. So firstly, you have to add the frequency series wise. Like for example, the first frequency is 12. So you just write 12 as it is in the CF column. Okay. The next one is 14. So you have to add first two frequencies, that is 12 plus 14, which is equal to 26. So it is your second CF. Then the third frequency is 8. So again you have to add all three frequencies, that is 12 plus 14 plus 8, that is 34. So 34 is your third. Just like this you have to add on the frequencies. So you will get one by one your cumulative frequencies, and then you will plot the class intervals on the x-axis and the cumulative frequencies on the y-axis. After that, just plot the points and you will get a rising curve. The second one is more than ogive. In the more than ogive, you will see that in the graph we are getting a declining curve. Okay, the curve is decreasing. So basically whenever we are having class interval and frequencies, so firstly we have to add all the frequencies. So after adding all the frequencies like 2 plus 8 plus 12 plus 24 plus 38 plus 16, after adding all of them you will get a number that is equal to 100. Okay, so first CF would be 100. After that you have to subtract the frequencies series wise. Like from the first CF 100 you have to subtract the first frequency, that is 2. So 100 minus 2, that is 98. Again in the 98 you will subtract the second frequency, that is 98 minus 8, that is equal to 90. So 90 would be your third CF. After that again you have to plot class intervals on the x-axis and on the y-axis the CF. After plotting the points and then connecting the points you will get a declining curve. So here all the graphical representations are completed. Now we will start the next topic, that is measure of central tendency. Now we are going to focus on the calculative part of business statistics. So we are mostly we are having the two main calculative part, that is measure of central tendency and measure of dispersion. Firstly, let's start with measure of central tendency. So let's start with the definition. The central tendency is stated as the statistical measure that represents the single value of the entire distribution or a data set. It aims to provide an accurate description of the entire data in the distribution. The central tendency of the data set can be found out using three important measures, namely mean, mode, and median. So basically what is measure of central tendency, where whenever we are having a bulk of numbers, that is called a data set. After having a data set, if someone wants to know that what is the measure of central tendency, like what is the central part of this data set, so you can just divide the data set into two equal parts. Okay, so it will be less calculative and you can just see the range of the data as well, right? So whenever you have to calculate the central part of any data set, then there are three methods: mean, mode, and median. Okay, first is mean, that is the very simple calculative part of measure of central tendency. Now, next is measure of central tendency are summary statistics that represents the center point or typical value of a data set. Examples of these measure include the mean, median, and mode. These statistics indicate where most values in a distribution fall and are also referred to as central location of a distribution. In statistics, the mean, median, and mode are the three most common measures of central tendency. Each one calculates the central point using a different method. Choosing the best measure of central tendency depends on the type of data you have. Now, first one is mean. Okay, what is mean? So the most popular and widely used measure of representing the entire data by one value is known as arithmetic mean. Its value is obtained by adding together all the items and dividing this total by the number of items. So basically it is a very simple method to calculate the central part of any data set. Basically mean is generally known as average of any data set. So whenever you are having like too many numbers, you just have to add those numbers and then divide it by number of observation, like you have to count the numbers. So if there are 5 numbers, just divide it by 5, so you will get an average number. Now, we are having in the calculative part two kinds of data. First is grouped data, second is ungrouped data. And the formulas are also different for ungrouped and grouped data. So, in the ungrouped data, you will have the data values only. That is denoted by X. Okay, and mean is generally denoted by X bar. So what is the formula for X bar? It is equal to summation of X divided by N, where X are the values, summation means addition. Here as you can see the sign, the horizontal M like structure, right? That is called summation, and summation meaning addition of x values. Okay, so x are the values and n are the number of observations, or I can say number of items. Similarly, for the grouped data, in the grouped data the frequency will also given in the question. So again, x bar is equal to summation of f into x divided by n, where x is the values of x, f is the frequency of x, and n is the number of observations or number of items. Let's see some examples so you can understand better. Now, here a data of ungrouped set is already given in the question, like 5, 10, 15, 20. These are the values of x and you have to find the mean. So what you're going to do is just adding all the numbers like 5 plus 10 plus 15 plus 20 and so on till the last number, which is 50. Okay, then divided by how many numbers are there. Now you have to count the numbers. So 1, 2, 3, 4. So there are 10 numbers. Okay, so add all the numbers and divide it by 10. Okay, after that you will get your mean, that is 27.5. This is for the ungrouped data. For the grouped data, you will be given the class intervals and the frequencies. Okay, in this method you have to firstly calculate the values of x. As you can see in the question, x values are not given in the question. There is only two values. First is classes, second is frequency. So how will you calculate the values of x? So don't worry, there is a formula to calculate x as well, that is upper limit plus lower limit divided by 2. So you just have to add all the two up limits of one class and then divide it by 2. Like for the first class it is 20 to 30. So add both the limits 20 plus 30 and divide it by 2. So you will get your first value of x, that is 25, just like given in the presentation. Okay, after calculating all the values of x, now you have to calculate the value of x for each class, like 20 to 30, 30 to 40, 40 to 50, like for the each class. After calculating all the values of x, then you have to create another column as f into x. Okay, in this you have to multiply each value of x to its respective value of f. Like for the first, the value of f is 8 and the value of x is 25. So 8 into 25, that is 200. Just like in the table, as you can see. So there is four columns. First for the class interval, second for the frequency, third for the x values, and fourth for the x into f values. Okay. After calculating the values of f into x, you have to add all the values. Okay, that is called summation. So adding all the values of f into x, then adding all the values of f, just like in the formula. After that you have to put all the, like I have already shaded the part like 4600 and 100. Okay, then divide all the two values, then you will get your mean. So there is different formula for ungrouped data and for the grouped data. Okay, after that, applications of mean. Now there are various applications as well. First one is comparing groups. The mean can be used to compare the average values of different groups or populations. For example, you can compare the mean training hours of women to the mean training hours of all the employees. Second one is calculating costs. The mean can be calculate the total cost of an action for a group of people when you only know the mean value of the group. For example, you can calculate the cost of a 5% wage increase for all employees if you know the mean wage and the number of employees. Okay. Third one is finding averages. The mean can be used to find averages like average monthly income, output per machine, and profit per unit circle. Then predicting futures. Predicting future values, the mean can be used as a starting point in prediction models such as regression analysis to predict future values.